So I hope you got your chain rule all right. Now as I said, even if you have a very simple question like d of sine x by dx, x is multiplied to sine x, this first of all is not equal to, a big not equal to, d of x by dx into, it's not a differentiation of sine x and differentiation of x. You see in your head you can read, I'll differentiate this, I'll differentiate that and multiply. When you read that in your head, you write that and see how bad it looks. Differentiation of x means dx by dx. Differentiation of sine x means d of sine x by dx. Does the math look alright over here? Does the math look alright? You have a dx into dx. Forget about the numerator if you are not able to comprehend. Dx into dx. Did we have a dx whole square? No, we did not. We did not. So you can't simply change stuff like that. You can't simply make it like that. A dx into a dx, that again, this again is absolutely not what this is. This and this are way different. So when you just look at this and say, oh, they said to differentiate x into sine x, I'll differentiate x, I'll differentiate sine x, and I'll multiply that, I'll multiply those. Should that work? Will that work? Now you shouldn't be asking that question at all. Will it work? It doesn't work if I say it works. If I tell you, yeah, it will work. It doesn't work. Because the math is not right. The math is not right at all. So when we split the plus thing, were you seeing that it was almost as the BODMAS rule, and it was going by the brackets, the math was absolutely alright. But if you are not convinced, it was something like change of x plus t is change of x plus change of t. X changes by 1, t changes by 2, x plus t changes by 3. So that is a change of 3. Or you can separately say that a x changed by 1 and a t changed by 2 and it is 3. That was all right. So when it was plus and minus, it was all right. When it is a multiplication, it is not all right. It is not all right. Like delta of x into t. X changed by 2, t changed by 3. Now x into t changed by how much depends on how much was the x. If x was a 10 and t was a 10, then 10 plus 2 is 12. 10 plus 3 is 13. 12 into 13 is a certain value. How much is 12 into 13? 12 into 12 is 144. And then a 12 again. So 156. Right? Right? So if it was a 10 and this was a 10, 10 and 10, the multiplication was 100. xt was 100. When x changed by, when delta x is equal to 2, delta t is equal to 3, x changed by 2, t changed by 3, then the multiplication, the new multiplication, xt is 156 now. 156. So the change in xt, is 56. Can you see that? Is the change in xt, which is not at all equal to change in x into change in t. Change in x was 2 and change in t was 3. Is it equal to 2 into 3? I hope you know that 56 is not equal to 6, boss. 56 is not 6, right? So whichever way you think, it is not going to happen, provided you think a bit what you are doing. So just don't read that I am differentiating x into sine x. Should it be equal to differentiation of x into differentiation of sine x? The differentiation means what? A change. And then apply, or just write the math that you were saying that should it be equal to this into this. Obviously it is not. the math doesn't look good or same at all, this expression doesn't even look like this expression, then how can the differentiation of this into this be a differentiation of this into differentiation of that? Not at all. And then I showed you a bit of algebra over there. I took an example over there to show you. I put a delta because I'm putting big numbers over here. You can put a D and imagine very, very small numbers, and the same thing will happen, that this will not be equal to that. It won't be equal to that. So now that we know that it is not equal to that, how do we do? How do we do? So we have a rule for it. How has the rule come? Through the basics. And in math, we are going to do that. So this class doesn't involve proving the product rule. It's a very easy proof. It will be fun for you if you have time to prove it yourself. Not a big deal. But on proving, what we get? Like this, we proved it. On proving, we got this, and we were using that. We were never even thinking of what was the proof. So the product rule is, if you have two functions of x, say u and v, fx and gx, but I'm not writing fx and gx, it will look like little cumbersome. So u is a function of x. In the given example, u is x and v is sin x. If two things are multiplied and differentiation with respect to a dependent variable, the variable on which it is depending, the main variable, differentiation with respect to that is asked, then the answer is, you take one of the functions out first, say v out, and differentiate u with respect to x, and then pick the other function, take that out, take u out, and differentiate v with respect to x. So today, the only requirement from you is applying this formula correctly. Not that how you got it. How you got it, if you do yourself, that would be good, that would be cool. So you have to apply the formula. So I'll repeat what the formula is. If two functions are multiplied, first, you don't differentiate one, you just take it out, don't even touch it, and just differentiate the other one. Plus, the one which you have not differentiated, the one which you have differentiated, that you don't differentiate, and the one you have not differentiated, differentiate that one. Is that clear? Is that clear? Shall we apply in this? Shall we apply the formula for this one? So let's apply. So say this becomes a question. D of x sin x by dx. That's your function. So sin x into sin x. So first take one of them out. What would you like to take out? Any one. So say x out. Because you can always write x into sin x or sin x into x. How does it matter? So x out. I'm not touching x. I have to differentiate sin x. I differentiate sin x with respect to x. Plus, now I'm not touching sin x. I'm not touching this. And I'm differentiating the one which I had not differentiated. X with respect to x. What is this? What is this? What do you get? What do you get? You get an x. Sin x differentiation is cos x plus sin x dx by dx is 1. So that's your answer. Look at it carefully. Understand how it worked. How you apply. Pretty cheap, pretty easy. The guys who are suspecting this rule, the guys who are skeptical about it, whether this is the right answer or not, because you don't know integration yet, that you'll integrate it back and get that thing. You don't know that stuff yet. You are skeptical. Then you can try out something what you already know. One is the question which I gave right in the starting of the class. So I'll do that again. But let me see what is d of x power 5 by dx. What is that? Answer is for sure. Answer is 5x power 4, right? right? That's the answer. But then I'm having a bit of scientific mind or mathematical mind, and I want to verify using a known thing. So this differentiation is known. I want to verify this formula. So I'll write this x power 5 as x square into x cube, right? Dx. So it looks like this. X square into x cube is x power 5. Now apply the formula and see whether you are getting a 5x power 4 or not. Do it fast. Pause the video. Okay, I hope you have done it. I hope you have done it. What is it? I'll take one of the thing out, x square out, differentiate the other thing. What is the differentiation of x cube? It is a 3x square. Plus, I'll take the other guy out. What is that? What is that? X cube out and differentiate x square. What do I get? 2x on differentiating x square. I'll get a 2x. Can I add those? Yes, we have x power 4. Thank God we have x power 4 here also. So we have x power 4 both the sides. So we can add those. And what do we get? We have 3x power 4 and we have a 2x power 4. 3x power 4 plus 2x power 4 is 5x power 4, which was the answer, which is the answer. So the rule is working all right for this. I hope it is working for everything. It does work for everything. So that's your product rule. So I'll just give you one question on it and then go on to quotient rule. Okay, do this. In fact, do one more, a multiplication of 3 functions over here, and see how you can use this formula to handle this. It's in fact a repeat use of this formula to handle this. And then sin x, this is a simpler one, into cos x. Sin x into cos x by dx. Now, through trigonometry, we know sin 2x is equal to 2 sin x cos x. That is through trigonometry. So apply this and see what's the answer. Apply the product rule and see what the answer. But then if the answer doesn't come exact same, but that doesn't look exact same, but they may be the same answers, because this doesn't look like this, but maybe they are the same answer. Maybe those are the same answer if you know enough of trigonometry. So once you have done trigonometry, you can use trigonometrical identities, and you may use the relations in trigonometry to reduce some of the functions and make your differentiation easier than otherwise. So I hope I hope you are understanding what I am saying. But to check out your product rule, do this one, and do this one by product rule. I am not testing your trigonometry over here. Okay, I hope you get all the 3 right so that I can quickly go on to the quotient rule, and that ends the session.